Thank you for joining today's webinar, Learning to Rank for Improved Search Results in Fusion 4. Today's presenter is Lucidworks Senior Data Engineer, Andy Liu, and Lucidworks Technical Engagement Manager, Andy Oliver, will be moderating the Q&A portion of this webinar. Thanks for joining us today, guys.
Thanks, Janessa. So first off, this is Andy Oliver, and before Andy Liu begins, I'd like to tell you a little bit about Lucidworks. Lucidworks is a company focused on AI-powered search solutions, both in the cloud and on-premise. The company is based in San Francisco with offices around the world and is relied upon by many of the world's largest companies. Our award-winning platform Fusion combines Spark and Solr with search-focused AI and machine learning capabilities and an app development framework, as well as insights and analytics in order to help your users and customers find exactly what they're looking for. Let's talk a little bit about our Fusion 4 release. Fusion 4 adds the app concept, which allows you to combine multiple collections into a single application. This includes our new App Studio web-based applications framework. Fusion 4 also adds app insights, which allow you to get charts and reports out of what users are doing in your search application. We'll highlight the learning to rank features in this presentation. In this release, there are built-in machine learning jobs executed on Apache Spark, allowing you to perform common AI-powered tasks in your search applications, such as classification, clustering, or head and tail analysis. This release adds a connectors SDK, making it easier to create custom connectors. Aside from these features, there are numerous improvements in the search engine, including scalability improvements. You can find out more about what's new in Fusion 4 on our website or from the previously recorded webinar. Without further ado, I'll turn this over to Andy Liu, who will tell you all about Fusion 4's new Learning to Rank feature provided by Solr 7.
Thanks, Andy, and thanks for joining everyone. Let's start our webinar today by thinking about the problems with classic models of relevance. The core algorithm of search is called TF-IDF, and Solr uses an algorithm called BM25 that improves upon TF-IDF, but the basic idea is the same. If a distinctive term appears more frequently in a document, then that document is more relevant for that term. This is good enough for most searches of most document collections. However, there are times when just looking at keywords are not enough to accurately capture user intent. To illustrate, let me show you an example that Chao Han, our VP of Data Science, gave in our last webinar. Imagine that a user searches for outdoor rock speaker and sees the results on the left. The search results are ranked according to how often these words appear in these particular documents in the way that you would expect. However, the term rock is ambiguous. Depending on the context, rock can refer to a type of music, or it can be a geological term. So it turns out in this case that the user actually wanted a speaker shaped like a rock, something that looks more like the results on the right. This is an example of a keyword search that does not match user intent. To summarize, Solr and Fusion's default BM25 algorithm is a good general-purpose scoring model. Improving upon it is somewhat difficult, especially in a global, systematic fashion, and not in an ad hoc, case-by-case, whack-a-mole basis. But perhaps for your enterprise, there are many valuable business-specific, non-keyword-based relevance factors you want to leverage. In these cases, keyword search just isn't enough. So one of the ways Fusion 4 and Solr 7 allow you to address this problem of relevance is through an algorithm called Learning to Rank. So what is Learning to Rank? Learning to Rank is a machine learning technique where we teach the computer how to rank items. We do this by choosing features, which you can think of as relevancy factors, that we think the algorithm should weight and tune. We also need a source of ground truth or order, One source of this is user behavior. Luckily, Solr provides some nice basic building blocks for implementing learning to rank. And meanwhile, Fusion provides a way of capturing user behavior as well as pipelines for applying these techniques. In order to understand learning to rank, let's draw an analogy from the problem of spam classification, which everyone is familiar with. The goal of spam classification is to accurately predict whether or not an email is spam on the basis of different characteristics or features of email. Interesting features that could provide clues as to how spammy an email might be, the kinds of words it contains, or perhaps the number of URLs it contains, or whether or not the email is from a known user. So machine learning is used to learn a function is spam, which is trained using existing emails in order to generate predictions for new emails with a high degree of accuracy. Similarly, in a learning to rank model, instead of using machine learning to predict spam, we use machine learning to predict whether or not a query, like iPad, is relevant to a document. The features used to feed the model are similar kinds of relevance factors that you would use to feed a Solr ranking function. Things like the score of title matches, or the score of body matches, or perhaps the number of views a document has. Similar to how a spam classifier learns from training data in the form of emails, learning to rank models are trained in the same way, but with ground truth relevance labels. Fusion offers a powerful and convenient platform for building learning to rank models. In particular, Fusion Signals captures user behavior like user clicks, queries, and other details. These signals are captured either automatically if you are using our App Studio products, or programmatically otherwise. Either way, signal events are sent to Fusion via a REST endpoint as JSON, and these events are captured by Fusion in a special type of collection called signals, and periodically aggregated into aggregate signals for efficiency reasons. By default, Fusion uses these to boost documents that are more often clicked or purchased for a given query. Learning to rank is able to turn these signals into improved relevance by using state-of-the-art machine learning algorithms to automatically blend user behavior signals with more traditional textual relevance factors. This algorithmic blend of text and context potentially offers superior search relevance with far less manual tuning. So what do you need in order to get started with learning to rank? First, we need to decide on which features to feed the model. You could think of features as relevancy factors like title match score, body match score, or signal-based features. Next, we use Fusion Signals to create ground truth from clickstream data. Ground truth is simply a large list of queries and the most relevant documents for each query. Lastly, we use Solr's learning to rank implementation to help us train a learning to rank model. Before we get too deep, there are a few things to consider. Definitely try just normal Fusion Signals and boosting before you try learning to rank. It may be good enough or possibly great for your corpus. Also be sure you've done all of your relevancy tuning first. LTR does introduce some complexity, so it is more or less a last mile technique. When using click signals for ground truth, there are some things to be aware of. On one hand, click signals are voluminous, cheap, and on the whole, reflect a user's intent, especially when supplemented with purchase or add to cart events. On the other hand, click signals can be noisy because users tend to click the first result and not even notice the second result, so this can self-reinforce what your keyword search was doing anyhow. The alternative to using click signals for ground truth is to produce them manually or through crowdsourcing, which is more expensive, but also more accurate. Let's look at how you do this in an overview. So I'm not going to go over this step by step, as we have a technical paper that already does that. Instead, we'll just look at the bigger picture of how the parts fit together. So here's the big picture workflow for how to implement learning to rank. In this diagram, I'm just going to start with step number 1 in the lower left and follow where the arrows point. So number 1, we upload a set of features via Solr's JSON REST API. Next, using Fusion signals, we produce a ground truth ordering of our results. And once we have that, we can use a Spark job to extract feature vectors for each query. Number 4, the feature vectors are then used to the feature vectors serve as input to the LTR model trainer. Number 5, once the model is trained, we upload it to Fusion. And 6, lastly, a custom Fusion query pipeline will handle future user queries. And when they query again, they'll see the results in the order provided by our learning to rank model. If you grab the technical paper from our website, it will walk you through implementing this using the Best Buy dataset, which you can download from the Kaggle website. In the sample code provided, I run the full end-to-end LTR training pipeline to train a few different models, namely straight out of the box Solr on textual features only, the logistic regression model using all features except signal features, and a logistic regression model using all features including signal features. The performance metric I use in this graph is recall at 5, which is simply for a given query, what percentage of relevant documents appear in the first 5 results, averaged over all queries in a held-out test ground truth set. The signal feature used applies a query-aware boost to documents that are more frequently clicked or purchased. The learning to rank model will automatically weigh this feature along with all other textual features in order to maximize relevance according to our metric. As you can see from the graph, there are significant relevance improvements observed over out-of-the-box Solr BM25 ranking, and even over the logistic regression trained model when using signal features. While the goal of this tutorial is to demonstrate how to implement learning to rank, and not necessarily how to produce the most accurate model, it's nice to see that leveraging Fusion signals can easily yield significant gains in relevance, even when we use them in a relatively casual way. So let's sum up the key benefits of using LTR. Using learning to rank offers us a way to automatically tune relevance. Meanwhile, using Fusion signals, pipelines, and job management reduces the time and complexity required to train and deploy LTR models in production. Using Fusion signals, you can do learning to rank and provide better results than keyword search alone. With all that said, do all of this carefully. Fusion 4 includes an A/B testing facility that will let you see whether LTR is better for your data set with your use case. A/B experiments work by directing a subset of your traffic to the new LTR pipeline and seeing if more users found what they needed. If you're interested in trying learning to rank on Fusion, grab the technical paper from our website, and you'll also find the code required in our GitHub repository. So to learn more, again, you can check out my step-by-step technical paper, and you can also take a look at our recording of a previous webinar of a Fusion 4 overview. And lastly, I'd like to mention that we have an upcoming webinar on Lucidworks Site Search, which is a cloud-based way of implementing search for your website. So go ahead and register for it.
Thanks, Andy. Now we've come to the Q&A section of the webinar. So if we don't get to your question today, then someone from Lucidworks team will reach out to you. We'll start with the first question. And please feel free to enter any additional questions into the chat tool, and we'll try to answer them. So first question is, can you, for you, Andy, is can we do this? Can you do this with just Solr?
Yes, you can, although it may be pretty difficult. And as I was saying before, Solr only provides basic building blocks for LTR. So I would say API level, library level functions for handling the low level details of scoring documents using an LTR model. It doesn't actually contain any components that allow you to do the offline training of an LTR model, which is kind of the bulk of the work of implementing LTR. So additionally, it's actually kind of difficult to configure and to set up. So Fusion offers a lot of really nice ways of editing your Solr config.xml or adding features via the admin UI, and that helps you save a ton of time and saves you a lot of trouble when trying to implement LTR. Query pipelines will save you a ton of time. A lot of implementing LTR involves just tweaking the different query parameters that the LTR component needs, and query pipelines allows you to preview results easily, and the ability to do live A/B testing and all the nice things that query pipelines allows you to do. So I would say yes, you can use Solr alone, but it's going to require a good amount of work to get that going.
All right. So we have another question. So what could be good signals other than just clicks for learning to rank?
Yeah, that's a great question. So it depends on the domain. So clicks are what I would say a source of implicit feedback that is relatively, and then depends on the context, but it can be a little bit noisy. So I guess the question is like, okay, are there other sources of implicit feedback that may not be as noisy? So e-commerce is a little bit easier, right? So if somebody searches for something, clicks a document, then adds that item to a cart and actually purchases it, that's something that you can track. And if a user purchases an item and search for these words when they found that item and purchased it, that's probably a pretty strong source of supervision for LTR. And then in other industries, there might be some analogies to that. So, however you think of conversion in your context, or the key performance metrics that you measure when trying to judge how well your search results are doing, I think it kind of points to different places where you can look to gather sources of user behavior that might be useful for you to either train your LTR pipeline or to use as features in an LTR pipeline.
All right, outstanding. The next question is learning to rank available in Fusion for Fusion 3?
So let's see. So Fusion 3 does contain a version of Solr that has learning to rank, I believe. I'll have to double check on that, but it's going to be an older version of Solr, so I think it may not have all the features that the latest versions of Solr has, and yeah, but as far as the query pipelines and the configuration capabilities, those are available for Fusion 3. So I think beyond that, I mean, they should be relatively the same.
All right, great. So next question would it be possible to use time to click as a boost?
Yeah, I mean, these are all different features that you can feed into an LTR model. So, instead of using, this user clicked this document when searching for this, you can also, consider how long it took them to click that document and feed that into an LTR model. So the nice thing about LTR in general is that it allows you to experiment with different features, and you're able to run this offline evaluation and training pipeline that tells you immediately how well you're doing, how well your model is performing, and allows you to kind of iterate on different features. So, which brings up another point. I mean, it's just so important to measure the effectiveness of your search. So, the metrics that, for example, recall precision and all those metrics that we use, I think, even beyond LTR, like it's having these metrics to be able to judge how well you're doing, be able to tune your search without necessarily A/B testing everything, right? So being able to measure how well you're doing in an offline setting, and then iterating on that quickly and promoting your best pipelines to production to see how well you do. I think that's the best way to kind of quickly iterate and provide best relevance for your users.
All right. How much training data do you need to make this really work? So assuming you don't have click data and you have to actually create training examples.
Yeah, I mean that's a great question. I think that's a question that everybody always asks, because it's obviously a very, very important question. And unfortunately, there's no set in stone example. It always really just depends. And this is where kind of knowing a little bit about the data science kind of helps you, because data science does offer kind of statistically sound ways of trying to judge how much training data you need. But as kind of like a rule of thumb, I would say if you're just starting with LTR, having at least a few hundred of your most valuable from a business perspective queries, having those as ground truth, and kind of measuring how well your search pipelines are doing with respect to your ground truth is just a really good place to start. And then from there, then you can kind of experiment with using more sophisticated LTR techniques to see if you can do this whole feature based and iterate and try to provide the most relevant results based on these factors.
All right. Next question. So the question is LTR aggregated among all users? And could you cache the query result via a CDN if needed?
So I don't quite understand the first part of the question.
I guess is the learning to rank results aggregated among all of the users?
Are the learning to rank results, are they the same for all users? Or I guess if the question is, can you personalize each user's search experience using LTR? The answer is yes, you can do that. Although it would be more complex to do that, because you're feeding in features that are user specific now, which are going to be dynamic based on each user that comes in. So the way that you train and test an LTR pipeline to do that, it's going to be naturally more complex. And as far as using CDN goes, yes, absolutely, you can use a CDN to cache the results of LTR, just in the same way that you can use CDN to cache any kind of Solr or search result page.
All right, great. There were clarifications, but I think you answered it basically, whether they could be personal or whether they could be among all users, and I think you captured that. So next question is, don't you have some kind of bias using click data as features? And is there a way to devise the ground truth for the learning process?
Yes, absolutely. There can be bias introduced, and as I was mentioning in the slides, people are going to be biased towards the first and second and third results. They're going to be more likely to click on those results than others. So, how do you account for that bias? A few different ways. One, you need a lot of data. So I think a lot of data can help alleviate some of the noisy signals. Another technique that I've seen is that you can run aggregations over your signals or over your clicks. So, for a given query, what are the top 3 documents that are clicked? And let me optimize or let me use these as ground truth. So in the process of aggregating, you're taking a more statistically significant number of samples to create ground truth. Another thing that I mentioned is, if you can go beyond clicks in some kind of way, kind of measure conversion in a more definite way, using add to cart or using purchase events, I would go for that first. There are algorithmic ways that can correct and account for this bias, although it's a little bit out of the scope of this particular webinar to talk about that. But it's certainly something that you can do research on, and it is something that is fairly well implemented and well studied. But beyond that, I think it's always a good idea to try to have some sort of ground truth that's manually curated, and it really doesn't take that much time to put together a couple hundred queries. It more than pays for itself after going through, I don't know, the days or even a week to kind of put that together.
All right. So sort of on that same basis, how would you account for the bias that users might be just clicking on the most recent items in the catalog page for an e-commerce site?
Yeah, I think I somewhat already covered that in my last answer, but yeah, there are ways to account for that algorithmically. So the way you do that is you kind of measure on average the click-through rates for each of the ranks, regardless of whether or not the document is relevant, and then you want to account for that bias within this click bias within the algorithm itself. So again, I'm not going to go into too much of the gory details of doing that.
All right. So another question is, and we may have to take this one offline because it's more about A/B testing, but can you A/B test using different signals, as in which signals are the most effective?
Oh yeah, absolutely. That's what makes Fusion, using Fusion with LTR so powerful. I think anything that you can do with query pipelines, you can do with LTR, because you can configure a query pipeline to use an LTR model. You can train multiple LTR models and then configure multiple query pipelines, and you can measure them all all independently and side by side in the same way that you normally would. So create your query pipelines and A/B test away.
All right. So the next question is, Solr supports scaling in feature values in LTR, provided predefined min-max values. But what if we want to scale our attributes dynamically based on the values of those fields in the result set?
So there are a few different normalizers, and I think you're right. There's a min and max. There's a z-score normalizer as well. And as far as dynamically, all the scaling is done dynamically. So whenever you run a query, if you have a normalizer configured, it's going to automatically scale everything according to the parameters of your normalizer. So, if it's z-score, then it's going to take the standard deviation and mean that you've configured the normalizer with and scale everything with respect to those values. So, all that's dynamic already. And the main thing that you have to worry about is make sure that you're scaling things in the same way in your query pipeline and during query time, in the same way that you've normalized your feature values during training. And
all right,
incidentally, just to add, in the GitHub repo, it does show an example of z-score normalizing features during training time, and then also configuring a normalizer during query time.
All right. So does LTR impact query performance?
The short answer is yes. The long answer is it depends on many different factors. I would say the main thing that it depends on is the kinds of features that you've configured and how many features you've configured. So, if you have 100 different relevancy factors, all of which require some kind of Solr search to kind of calculate, that can be fairly costly. So it's going to be just a matter of experimenting to see, testing both the accuracy of your LTR model and also testing the performance impact of those different models. And it could be that there's one model that's less accurate, but it's far faster at query time, and you've done the calculation that adding 100 or 200 milliseconds of latency costs this much in real dollars to me, so I'm willing to settle for a less accurate LTR model. So it's all there's always this performance / accuracy trade-off whenever you're doing any kind of machine learning, and especially LTR.
And I think one thing I'd like to emphasize is that this really, again, goes back to that new A/B testing feature in Fusion 4, in that you can basically have two pipelines side by side and run an experiment, sending some user traffic to one and the other, and then and from there you can look at the results in the new Fusion Insights and see a nice graph of what that click-through rate or whatever your performance measure is. So definitely, when you're doing these sorts of things, definitely A/B test and see what the difference is. And that particular feature of Fusion 4, I mean, there's other ways to do it, but that particular feature of Fusion 4 is a nice new feature. All right. So how does LTR deal with sparse features? For example, categorical feature that has over 100 unique values. Can the model deal with those efficiently?
Yeah, it depends on the kind of LTR model you're training. So in the GitHub repo, I demonstrate how to train a model using logistic regression. There are tons of different models that you can actually use to train train LTR. And each of these different algorithms deal with features in a slightly different way. So, some algorithms deal with categorical features better than others. So, so again, I think talking about the nitty-gritty of how to deal with this particular case is outside the scope of this webinar, but it kind of falls under the umbrella of data science best practices.
All right. How do you get enough clicks for all the documents to train the model? Do the documents that never appear always have a lower ranking?
Yeah, good question. So how do you get enough clicks? Well, first you need to be capturing your clicks, which is kind of obvious, but it's actually pretty crucial. I mean, a lot of cases, the main barrier to doing deep data analysis or doing things like LTR is the lack of capturing of data and the dirtiness of the data. So I think this is where Fusion really helps, because out of the box, Fusion will automatically kind of instrument all your searches and capture all the signals in a format that is consistent, and you don't have to worry about a lot of the nitty-gritty of kind of plugging into that data feed subsystem. Yeah, and then this is, so if you're only exclusively using clicks as labels, yeah, there is a cold start problem for new documents that are added. So again, I think LTR is kind of used in conjunction with different kinds of techniques for ensuring relevance, and I think if this is where kind of using clicks alone might hurt you, right? And the cold start problem is everywhere, especially in machine learning. It's one of the hardest problems to solve, because machine learning learns from previous data, and when you don't have previous data, there's nothing to learn from. So this is something that we're always trying to overcome when doing machine learning. But I think this is where having the manual ground truth can help. This is where some of the other kind of traditional ways of guiding relevance might be helpful in conjunction with LTR.
So would one of those options be using a random order scenario to get data for those documents?
Yeah. So one of the options is, for a certain random sample of queries, perturb the result list so that newer documents are boosted towards the first three positions, right? So that's kind of one of the tricks of the trade that are employed. So if we boost these up to the top, and for a small sample of users, they might not get the best search experience, right? Because this one document may not be relevant. And then if they don't click on it, then that they don't click on it, so that document's probably not going to be relevant in future queries. But if they do click on it, then that gives you valuable information from which you can predict future queries, and that kind of gets over, in some ways, this cold start problem.
All right. So I'll make this the last question, and actually I'll take two more questions, and then we'll wrap up. What if the documents are time sensitive, as in newer is better? Is the LTR model updated constantly? Right.
Great question. So you can input the age of each document as a feature. So the feature can be the age of a document in days, or however time granularity you care for, and that can be fed into an LTR model, and an LTR model can tell you whether or not a newer document tends to be clicked on or tends to be more relevant than older documents. And the nice thing is that it'll actually kind of, depending on the kind of model that you're using, it may give you some of this nonlinear kind of intuition behind these values. So say a document that is a day old is super relevant, but a document that's 3 days old is not really that relevant at all. In 4 days, it's kind of the same. So that's kind of the beauty of using LTR. You can feed these into the algorithm as features and see how the algorithm weights them, and you could also test to see if those features improve your overall metric.
All right. So last question here: why is there a performance impact from LTR? Wouldn't it just change the TF-IDF values in the index? Could you explain that a bit more and give an example?
Yeah, so the way that LTR is implemented in Solr, it kind of operates a little bit outside of the main scoring code path, I guess, so to speak. So what it's going to do is that it's going to retrieve the top, say, 200 documents using traditional TF-IDF, and then with those 200 documents, it's going to perform feature extraction on those 200 and then resort them according to the model. So it's really in this feature extraction step that adds computational complexity. And the reason why we only do it for 200 documents is that to do it for all of the documents in your entire corpus would be extremely costly. So what it does internally is it's going to grab the top 200 documents. We hope the relevant documents are at least in that 200, and then it's going to do all the feature extraction and resorting. And then in terms of how long that takes, this goes back to what I said before in terms of, okay, how many features do you have to find? How complex are those features? So it's really going to be dependent on the way that you've configured LTR at that point.
Would it matter if the search content was static as far as the performance goes?
No, it shouldn't matter. So
all right.
Solr handles all the details around dynamic documents and making sure they get indexed properly.
All right. Well, thanks, Andy. We're just about out of time. Thanks to everyone who joined. Everyone who registered for the webinar will receive a link to the recording shortly. If we didn't have time to answer your question here, please look out for a note from someone from Lucidworks. And if you have any questions, feel free to email events@lucidworks.com. Also, I'll note that if you go to our website and click on blog, there's a link that you can follow to the technical paper that we mentioned, as well as when you get the link to the recording. It was mentioned in the slides, so that you can actually follow step by step and reproduce the results on your own. Thanks again for everyone who joined us, and we hope you enjoyed the webinar. Thanks, guys.